All right, welcome to lesson 5 for chapter 15, still talking about water. Lesson 5 is focusing on water use planning issues. So learning goal is that you should be able to describe the challenges present in water use planning. And we have a couple success criteria. You should be able to describe some of the problems that are associated with stormwater runoff. You should be able to list sources of groundwater pollution, list the problems associated with water use planning, and then list the problems associated with groundwater mining, and explain the problem of salinization associated with large-scale irrigation in arid areas. All right, so historically, wastes were discharged into waterways with little regard for costs imposed on other users by the resulting decrease in water quality. The population has grown dramatically, and so domestic water use has intensified. There has not been enough water to satisfy everyone's needs. In metropolitan areas, they must deal with and provide 3 basic services. So anywhere that has like city structure and services, like where we live. So the first is water supply for human and industrial needs. There needs to be clean water that we can use to consume, to wash things, all of that. There needs to be wastewater collection and treatment so that we can then treat that. And then there also has to be stormwater collection and management. If there's not stormwater management, then that's what can lead to really bad flooding and destruction in the end. And then stormwater collection helps collect some of the pollutants that can end up there. So urban areas are paved, so it's not just dirt out in the city. We have cement and asphalt. So little water can be absorbed into the ground. Those aren't porous things. Water isn't being absorbed by the street. It's going to run off the street, which is why managing stormwater is a problem. So the Water Quality Act of 1987 requires that municipalities obtain permits for discharges of stormwater runoff so that non-point pollution sources can be controlled. Many cities have separated storm sewers from sanitary sewers to avoid contamination in time of flooding and heavy stormwater runoff. If those things are combined, when it starts to flood, some of that sewer water could be included in the flooding. So it's really important that those two are going to stay separate. Future issues that'll have to be addressed include increased demand that will generate pressure to divert water to high use areas. So we need to be able to get water to where it needs to go. There's also going to be increased demand for wastewater treatment and reusing existing water supplies. Salt buildup due to evaporation may also lower water quality. And then groundwater overpumping will cause the water tables to be lowered. Remember, the water table is the top of the water that's underground. Seawater intrusion in coastal aquifers will ruin water supplies. So aquifers are where the groundwater is held. And if those supplies are so low because the water table has lowered and then ocean water comes in, that's going to salinize or add salt to what was fresh water, which ruins that water supply for us. There will also be increased demand for water-based recreation, which demands high water quality. Swimming, boating, some types of fishing, we need clean water for those things. All right, so water diversion. So we can't say really if this was a natural river or not, but we can see that this water is being diverted multiple places. So water diversion is the process of transferring water from one area to another. It is seen as a necessity in many parts of the world. Instead of settling around water like we used to, we want to settle where we want, so we move water to those places. One major consequence of diverting water for irrigation and other purposes is water bodies downstream are deprived of their source of water. So if we say that this was what was natural, this area down here would be used to getting a ton of water, but now 2/3 of that water is going somewhere else. This can have serious ecological effects, and lake levels can decline, affecting fish and other wildlife populations. So salinization is the increase in salinity caused by growing salt concentrations in soil. The salinity of something is how much salt is there. As plants extract water from the ground, the salts present in all natural waters become concentrated. Irrigation of arid farmland can make salinization more acute due to increased evaporation rates. So we're adding water into what was pretty dry soil, so then that water is being taken up by plants or is evaporating, and that's leaving more salt. This is primarily a problem in areas that have been under irrigation for decades, and it can be very, very severe. This is salt. Groundwater mining is removing water from an aquifer faster than it can be replenished. Groundwater, if you remember from when we went over our water sources and how long things stay there, water is in groundwater for like thousands of years without really moving. So us removing groundwater with wells or whatever else, we are taking it faster and it can be replenished. So it's not something we can do forever. So extended periods of mining can lead to land settling. So water was filling up space underground, and then we're taking that water away, which means that the land's gonna, crumble in a little. Lowering of the water table and saltwater intrusion into wells near coastal areas. And this is what that looks like. So if this is our aquifer that, is flowing into the area towards the ocean. Here's our freshwater well. If we are taking up so much of that fresh water, then that salt water is going to push in and make it to the wells, and those are now unusable. Not so much a problem in Oklahoma. That area is closer to the ocean. That's a problem. An average of 85 billion gallons of groundwater are withdrawn daily in the U.S. That's significant. 90% of this water is used for irrigation, public supply to home, businesses, and industry. Irrigation accounts for 2/3 of the water, so irrigation for crops. Groundwater provides about half of the drinking water in the U.S. And rural areas depend on groundwater for drinking. So rural areas are where you tend to see wells versus more urban or like city areas are going to have water piped in from like water treatment plants and things like that. The use of groundwater increased between 1950 and 1975 in a lot of the world, not just in the U.S. Groundwater is used intensively in arid and semi-arid countries for irrigation, and it's been called a silent revolution because the arid means there's not a lot of water. So suddenly, magically, we're getting water out of the ground. That's amazing. For as long as it lasts and as long as we don't use all of it. Millions of independent farmers depend on groundwater, reaping social and economic benefits. There is little management by government water agencies. As many as 2 billion people worldwide depend on groundwater for drinking water. And a lot of people here are probably on wells as well. Groundwater sustainability is a trade-off between groundwater use and the long-term effects of that use. So we need to use realistically, we need to use groundwater occasionally, but it's not sustainable if we are using it all the time. So management strategies can include shifting from groundwater to surface water, importing water from outside the local water system boundaries, so diverting rivers, control pumping with guidelines, policies, taxes, or regulations. We could tax people who use it more or regulate how much is allowed to be pulled. And then there's also conservation practices, techniques, and technologies. Conservation is almost always a solution because chances are we are using more of it than we really, really need. So if we replan and make it so that we don't need to use quite as much water, there we go. We could also reuse wastewater, not like sewage water, but gray water, so water that was used for washing hands, dishes, things like that. And then also treated wastewater, which is called reclaimed water, for non-potable uses. So not like, okay, this is the water we're drinking, but maybe we're watering our lawn or watering the golf courses with, gray water, which is something that is done some places. And then there's also desalinization of brackish groundwater. So brackish means it's not saline, it's not full like salt ocean water, but it is a mix of salt water and fresh water. And then we also want to preserve scenic water areas and wildlife habitats. So not just, underground water, but these beautiful rivers, lakes, streams. Some bodies of water have unique scenic value. And the United States Federal Wild and Scenic Rivers Act of 1968 established a system to protect wild and scenic rivers from development. All federal agencies must consider the wild, scenic, or recreational values of certain rivers when planning and for the use of development of rivers and adjacent land. So if we have a river and someone's like, I want to put a farm right there, but it means they would be pulling a lot of water from the river, that would need to be considered. One huge semi-aquatic habitat that we've talked about before, but we're going to talk about again right now, is wetlands. So wetlands, it's wet, there's water there. There has been a huge loss of wetlands over the last century, 2 centuries. 30% of that has been lost to urban development. 21 is for rural development, 23 forestry, and 26% to agriculture. And historically, poorly drained areas were considered worthless. They're poorly drained. They're wetlands. They're supposed to hold on to water, so poorly drained. And were filled or drained and used as building sites. Less than half of the original wetland acreage remains. And in the U.S., 95% of the remaining 20 million hectares, which is 50 million acres, of wetlands are inland freshwater wetlands. We've lost a lot of the brackish ones, the ones close to the ocean. Only recently has the natural and economic importance of wetlands been recognized. Wetlands are incredible. They provide wildlife spawning and breeding habitats. We care about biodiversity and preserving other creatures. They are a natural water filtration system. So there are actually some areas where wetlands are actually a part of their water treatment process, because wetlands are just wonderful at cleaning water. They help to slow floodwaters, permitting nutrient settling, and they are also floodwater control. There are a million things that we love about wetlands and ways that it serves and helps human beings, but also the environment. Some of them are listed here. You can pause and read. But before you move on, see if you can answer these questions. So 1, why is stormwater management more of a problem in urban areas than in a rural area? Define groundwater mining, and then tell me, how does irrigation increase salinity? Specifically in arid areas is my hint for you. If you have any questions, please let me know, and I will see you in the next one.